the funders, everybody, pretty much everybody in the ʻIKE, because it teaches us things like real engineering design outside of the classroom. Like we're not in textbooks. There are going to be setbacks. We're learning from our mistakes. It's a real learning. We learn how to manage our projects. We learn how to budget. We learn how to put things together. Laulimo, there's many people working together in a team, and this is a chance to incorporate our culture in it, our culture in everything.
So we'd like to acknowledge NHSCMP, the Native Hawaiian Science and Engineering Mentorship Program, the ʻIKE SEE3 coordinators, our mentors, Mike Menendez, Dave Horton, Brendan Minier, and the 2012 ʻIKE SEE3 students.
What was the main stumbling block? What kept you from completing this? What would you attribute that to?
Time and having to go through the purchase order process.
Welcome to our world.
Is it like we can really get some native creatures in the fish tank?
Oh yeah, those stream gobies, we can catch them in Manoa. We just gotta kind of walk up a bit, or we can go to like the water stream. As for the plants, there are many nurseries around the island. Like Huiku is one of them. They grow and they'll sell it to people. Yeah, it's available.
I saw in one of the SolidWorks renderings you had the water. Did you use SolidWorks to analyze the loads of the water to design the stand?
I'm going to be honest, no, we didn't. Couldn't figure out how to make the water, so we just kind of made a box and stuck it in.
So it's just a blue box.
Still learning.
Any more questions? We're good? Thank you guys.
So our next group did an electric vehicle by Sterling Gaspon, Ada Garcia, and Jeff Oshiro.
All right, hello everyone. Thank you for coming to the symposium. I'm Jeff Oshiro.
I'm Sterling Gaston.
And I'm Arvin Niro.
And of course, we are participants in this year's SEE3 Summer Engineering Experience program. Today we're going to be presenting on a side project that we had the opportunity to work on, that the three of us had the opportunity to work on. This is the electric vehicle project. Just a little background about this, about the electric vehicle. So our mentors, Mike Menendez, Brendan Minet, Kyle Wong, and Dave Horton, they were at the time mentoring a group of high school students participating in the high school internship program at the College of Engineering. And so when we heard about that they were doing this project, we kind of, well, they asked to be part of it. I kind of saw that they were building a go-kart and they couldn't get rid of me. So yeah, so I just kind of jumped in on there. So the goal for this project was to do an applied engineering project in renewable energy. So what we wanted to do was, at the time we were going through all these different projects that all the guys presented earlier, the main goal was that we wanted to take all that we were learning about the engineering design process and apply it to a project in the field of renewable energy. So, big picture. So the medium project that we chose for this project was to build an electric go-kart. A couple reasons why we chose to do electric vehicle. One, cars are a huge part of our society. They have a huge impact on the economy, the environment. So we want to get an entry-level project to introduce us into that field. Another reason why was, it's building an electric go-kart, that's cool. Let's see. So why electric versus gasoline? I'm sure you all know that gasoline cars produce pollution, harmful emissions, whereas if you use an electric vehicle, you just run the guy and no problem. Per mile for electric vehicle, it's like 2 cents per mile to go to power your vehicle versus 12 cents per mile for electric car or for gasoline car. Again, it goes back to renewable energy. Gasoline is a fossil fuel, it's a finite resource, whereas like the guys presenting on the wind turbine project, there's advances going on with renewable energy. So electricity is a renewable source of energy. All right, and I was going to talk about the design process.
Okay, so to start the design process first, we had to decide on what project to work in, and we decided to go with the go-kart because everyone had a passion for cars. And the next thing we had to do is we had to discuss how to overcome the different constraints we were facing in order to bring this project to completion. One of our major constraints was time. We only had 5 weeks to complete this, and also budget. In order to have any funds to purchase any parts for the vehicle, we would have to fundraise, and we didn't have the time to do this. But lucky, Mike's company, that's one of our advisors, donated all the parts necessary to complete this project. After all the brainstorming, we had to do the research. First thing we researched was electric vehicles, go-karts. We also researched internal combustion engine cars, specifically gasoline. The reason why we did this was first to be able to compare electric cars to gasoline cars. And also we did this to be able to gain knowledge about the different components a regular car you use to go to work and school every day has, and how not integrating them into a go-kart would affect the latter. Some of these were, for example, suspensions and other components such as the differential on the rear axle. Okay, after all the research, it was time for designing the go-kart. First of all, like everybody else did, we drew it on paper and whiteboard, and then we used SolidWorks, which is used for design processes. After doing this, we were introduced to stress analysis using the SEE3 software on the computer. After all of this, it was time for the fabrication process. The first thing we did was grind and sand to bare metal. We did this to facilitate any work that we had to do on the go-kart, such as welding and cutting and everything else we were going to do after this. The next thing we did was chop the frame in half and remove any extra material we didn't need in the go-kart. And then we welded everything back together using MIG and TIG welding. For those who don't know, MIG stands for metal inner gas and TIG for tungsten inner gas. The reason why we removed all this material was to increase the power to weight ratio and also for improving the cornering radius. After doing this, we coated and prepped pipes, and we added it to the frame to increase strength and safety, and we also added a roll cage. Then after doing all of this, it was time to put mounts for our other components, the important ones such as the batteries, the motor, and the brakes. And I'm forgetting. Okay, so the next thing we did was spray paint the whole go-kart. We decided to go with black and red because it's our favorite colors. And after we did that, we put in all the components into our car, which are the ones I just mentioned and the ones I forgot. So after doing this, we put in also an all carbon fiber seat into our go-kart. And now we wire the whole system, which Sterling is gonna elaborate more.
Okay, so here's a picture of the frame before we painted it without any of the electrical drivetrain in it. It has a carbon fiber seat and it has the hoop roll cage, which we incorporated into this design. And so the last step of our fabrication process was we had to mount an electric motor that turned the chain and sprocket, which spun the rear axle of our go-kart, so it was rear-wheel drive. And after this, we had to wire it to a throttle controller and wire up all the batteries. Here's a simple throttle control schematic. It started off with the batteries. In our case, it was 4 12-volt batteries, which we wired in series to make it 24 volts, and then wired it parallel to make them last longer. This was wired to a controller, which was wired to a throttle, and this told the controller and the motor how fast to spin our rear axle. So there's a lot of technical skills that we learned over this whole process. We learned how to MIG weld, TIG weld, we learned how to cut steel, we learned how to grind, coat pipes, bend pipes, and electrical wiring. On top of the technical skills that we learned a lot of professional skills that we could use past this engineering project. We learned the engineering design process. We learned the best way to brainstorm and research. We learned a lot of project management, which in our case was staying on the timeline because we only had 5 weeks and we pretty much had 3 weeks to build it. And the last thing that we learned, which was really important, was budget. Like she said, Alice said, we had to fundraise for the parts, and there wasn't a lot of time for fundraising, so we were fortunate enough to get most of the parts donated. And the last thing, which was one of the most important things, was team dynamics. Because we were allowed to work with the high school students, we all had different skill sets and came from different backgrounds, and we're all at different education levels. So that was a big part of learning how to work together. Here's a picture of our final product. We're just charging up the batteries to test out everything. And we'd like to show you guys a video.
If there's time, it's a couple minutes. So.
Yeah, let's write it down. It's interesting.
So this was a video that was made by it's one of the mentors, David Hummer. And just kind of documenting the process. This is them, the high school students working on SolidWorks to design the various, or work on the various components for the go-kart.
There's a slider going on.
You're not doing nothing there. So yeah, so like, I don't know about Matt and Sterling, but I came into this project like knowing nothing about how to do welding or grinding. So lucky enough for me, like the mentor taking me out of the shop when I showed up, they were willing to teach us. They're really great teachers. Like Nate Horton, guy is green welding, so he's a very valuable resource. So I'm sure very about that.
Up in lights, he just wants to be heard, whether it's the beat of the mic. He feels so unlike everybody else, alone in spite of the fact that
so these are the high school interns, that's Hana and Justin.
He knows the code. It's not about the salary, it's all about reality. And making some noise, making a story, making sure his click stays up. That means when he puts it down, Tom's picking it up. Let's do the Hennessy anyway. He never really talks cost much. Never conserve a status, but still leaving them starstruck. Humble through opportunities, given this right to fact. That many misjudge him because he makes a living from writing raps. Put it together himself, got a picture connects. Never asking for someone's help, to get some respect. He's only focused on what he wrote. His will is beyond reach, and now it all unfolds. The skill of an artist. This is 20% skill, 80% fear, be 100% clear. His writing was ill. Who would have thought he'd be the one that set the Western flames? And I heard a record with the instrument, the name of the game. Came back, rock Megadeth, took him to church. I like Bleach, man. Why you had to scoop in his verse? This dude is the truth. Now everybody giving them guest spots and stocks through. This is 10% luck, 20% skill, 15% concentrated power of will, 5% pleasure, 50% pain, 100%.
So we'd like to thank the University of Hawaii Manoa College of Engineering. We'd like to thank NSF, ʻIKE, NHS CMP, Dr. Najad, our advisors, Michael Menendez, and mentors Dave Horton, Kai Wong, and Brendan Benet. And these guys did a lot for us. They taught us all of the technical skills that we needed to complete this project, and they were there through the late hours, like 3 o'clock in the morning while we were up playing in the shop and working on this project. And we'd like to thank David Hummer for helping us make that video, and the high school internship program, and all of the high school interns in our group that let us kind of work with them and tag along, Lana, Chris, Ben, and Justin. Thank you. Any questions? Yes.
How fast?
About 25 miles an hour.
Whoa.
But you don't want to go
That was in Florida, yes. That wasn't all the way, so.
Yeah. Yeah, you don't want to just, it's got no actual suspension, it's got all the suspension within the frame, so if you go that fast, like, it kind of hurts. Yeah. Yes.
What about brakes?
So, I'm sorry, what about brakes?
We had a handbrake,
Yeah.
so we had our master cylinder, and then instead of making a pedal brake, we ended up making like it would be like your e-brake in your car.
Okay.
So
That was my idea.
that was pretty
You had a
cool.
disc with some calipers, or?
Oh yeah, it was rear disc, yeah.
Yeah, it's just like a regular master slave system.
Yeah, it wasn't drum
My
brakes.
car, yeah.
It was rotors.
Okay, thank you.
Yeah.
If you had a bigger budget and more time, what improvements would you make?
We would have made it all-wheel drive, good suspension, rear diff. We would have put a bigger motor. Would have. Okay. We would have. What else would we have done?
Put a frame for safety around the go-kart. We weren't able to put a frame around it. We just left it with the steel pipe because we didn't have more time or funds for it.
We would have used all chromoly. We would have made it a lot cooler.
Put more carbon fiber.
Paint it some more. Put more rims. We would have put a stereo.
There's a competition for college students called Formula SEE, which our friends are doing their senior design project on now. So it's just like engineering students, they're building mini versions of Formula racers, and you know, it's all students, so it's all students, even the drivers are students. They're raising a budget, and for the next year they're going to be working on this car and building it. So if I had a bigger budget, that's what I would do. I'd make that thing electric, basically.
So we can talk about cars all day long, so we're gonna give time for the next students to give their
So we all know the blue screen of death. That was it. The Hawaii Adventure by Warren, Lidu, Caniela Fernandez, and Chris Amara.
So I'm subbing for Lee, because Lee couldn't come today, so I guess it's not. I'll sub in. So basically, the Hokai, we're gonna have slides about it later, but it's basically a trip or a voyage. Lots of times in school. Everyone.
Hello, I'm Alexander Fernandez.
My name is Warren.
My name is Chris Amaro.
My name is Sato. Is it your name? Yeah.
So today, with the ʻIKE group, we're just going to be presenting, informing you guys what ʻIKE is, what we did during our ʻIKE, where we went, give a little bit of our personal experiences, and end with the video.
So our presentation is not like the other ones. It's more of a fun day, like a fun adventure, and it's very cultural. It's not that scientific, so it's fun. It's a good ending. So basically, a ʻIKE, the literal meaning is like a trip or voyage, a journey. But last times in schools, you hear it used as like a field trip. But the way we kind of interpreted it as for our day was the adventure to discover something. And that discovery was a lot of cultural sites around the island. So we'll go.
Okay, so what we did was we had it modeled around The Amazing Race. I don't know if any of you have seen that show, but we were broken up into 7 teams. It was our SEE3 program with the Summer Bridge and Transfer Bridge programs that were at UHMNO over the summer. We were broken up into these 7 teams, and we were given these clues that we had to follow and to go to different cultural sites around the islands, around this island. And while we were each clue, when we got to each destination, we had a specific task that we had to do, whether it was like learning about the cultural significance of the area or like just fun things like taking pictures. That's fun.
So to speak about where we went, the first step was going to UH Holmes Hall around 8 o'clock in the morning, 7:30 in the morning. I got there at 8 on time. But we did finish at Kapiolani Bay Waianae. And the final chapter of the ʻIKE was to hike Ka Hana Ka Point, very hot. After that, we drove to YWCA in Kaneohe, and we started this ʻIKE as individual groups, set out on a mission, and at the very end, we all came together as one big ohana. We talked story and got to know each other as well as play games. We camped there overnight, and we returned to UH the following morning.
So I'm just going to talk about a couple of the places that we went that we felt were important. So of course, there is the iconic statues, if you guys are familiar with the ones that are on Oahu. We went to Dukanamoku statue, Queen Lilipu'o, Kalani statue, Kamehameha statue, St. Damien statue.
So one of the places we stopped at was in Nu'uanupali, and for those who don't know much about what the Nu'uanupali is, it basically was like a huge battle in like ancient Hawaiian history, and it had a huge impact on society and how we are today. So one of the tasks we had to do here was try to reenact like what happened. So one of the main things of the battle was they kind of forced lots of the guys off over the cliff. So you see these guys throwing Thailand over, and supposedly they have guns. So these are the guns are coming.
And one of the, well, a couple of the places that we went to were heiaus, and for those of you that don't know, a heiau is pretty much like a sacred site in Hawaiian culture. This one, the Ulupo heiau, is in Kailua.
So, go ahead.
Now, one of our sites that we had to visit was the Biohole Poi Factory. And we went there to help support local farming as well as buy local plates as well. Delicious food. And when my team got there, red team, best team ever, when we got there, the Poi Factory had, oh no, the Poi Factory was not open yet. So we weren't able to buy food yet, but it was a good sight to see.
So the next destination, because we're working our way up east, up to north, next spot that many of you are familiar with is Kulo Beach Park. So we have a couple of requirements for that area. One of them was like a swim meet kind of competition, like a race, and we had to take photo proof by taking a picture. Thank you, Clyde.
So yeah, our next destination is at Lydia Point, and over here there's like placards around the area. So we read about Lani Law, which I'm not gonna go in depth about it, but Lani Law is basically a mole or a giant lizard, and it became, or he or she became like the land at Lydia Point. So this task for us to do is to make a pyramid with someone that's not from your team. So this is my group, but we have a couple guys from other groups in our team.
Like I said, we visited a couple of heiaus, and this one, the Pu'uoka, was in Kupukea, up on that high place.
It's also known as one of Oahu's largest heiaus.
So the next place we went to was Kokani Loko, which is right outside Wahiawa. It's the birthplace of chiefs. So traditionally, they kind of mark Kokani Loko as like the center of the island, which is actually pretty close to where it is. This is where chiefs were born.
So some of our personal experiences, of course, in fact, we were on different teams. Me and Warren were on a team. Isaiah was on his own, and Chris. As you know, there were 7 teams, so we all kind of have our own experiences. You know, some teams really excelled, and some had other motivations. So in my personal experience, our team won. We also were able to prove it by cracking most media. Thank you. But for us, our team, what worked really well for us was our communication. We were from different parts of the island, our team members. So depending what part of the island we were at, we kind of had a feeling. One of us had a feeling for where we were going, and we were able to figure out what the clues were to the next and the next place.
So for my team, we were a little bit slower than Chris's team and the other team. So like Waihole Poi Factory was definitely open by the time we got there. And we were able to eat some food there. But we weren't as pushed to like winning as some other teams. We already started a bit slower, so we kind of took in the cultural experiences and took time on each site to enjoy ourselves. And it's important to know for this entire thing, we went to a lot of cultural sites, and there's a lot of, you shouldn't just be like running around there, so we made sure to tell everyone to pay their respects while they're
Okay. If you could hold your comments and questions to the end, we're gonna show a video. It's about 9 minutes. It's kind of lengthy, but it goes by really fast. Because imagine we started at 7:30 in the morning. Our team finished first. Got around the island.
Okay, we're gonna run a video during lunch. You can ask questions. Any questions?
Thank you.
What are your final outcomes, or what did you learn from it?
Of course, one of the main things was definitely having cultural experience, because lots of us in the program, like many of us are native Hawaiian, but not all of us have been to like these sites or know much about our culture. So this is kind of a way to get more immersed in the culture, because we are a native Hawaiian film program, so we wanted to have like sort of a basis to that. And another thing was also having like a fun day and like a good social activity, so you make bonds with people in your group and whatnot. You learn to work together.
Kind of along those lines, how did this cultural experience journey help you anything, become better engineers?
Well, the ʻIKE, I'm pretty sure it helped everybody learn to communicate with everybody in the group as well as other groups. We did work separately. Each group worked separately. And when we came together at the very end, we had such a great time. We learned how to communicate to each other and let each other know what we need help with during the ʻIKE as well as after the ʻIKE. Helping out, finding each site, or just helping around at the YWCA, helping each other out.
And something too, like chaos, for example, like they've been there for forever, and they had to have like not technically not called engineers, but they kind of were like engineers in ancient way. We kind of seen how they did things back then, so we can learn from them things there and improve.
Any more questions?
Do the must talk.
So I'll just introduce the next speakers, our MC, and Leisha was in SEE3 last year, so she's sharing a project they did last year as a transition to what will be the senior research projects following. So, do you have a video? Yeah. Okay, well, Dr. Najad hooks me up. I believe for ʻIKE, we were the first SEE3 that had a mass scale project. It included a WASP system, which was my project, wind and solar power, a UAV, an unmanned aerial vehicle, and a UTV, a utility vehicle built. Our three projects were specifically designed to help a local farmer in Kuhuku on his banana farm. And for me personally, our wind and solar power system was created to supply an off-grid system out of Hiko and power him with security lights for his property, as well as be a charging station for the UTV and UAV systems. Just like everyone else, we went through a engineering design process. Yeah. Sorry. Engineering design process where we first started out with research. So we had, because it's agricultural land, we had to check permits. We had to make sure that the farmer was okay with us placing our systems on his property. We also worked with SolidWorks, where we designed stress tests and designed our towers for the system. We also had to take into consideration that because we're in the middle of the ocean, that erosion would be any issues. So we bought our systems pre-made, and the main thing we did as a group was fabricate a 30 feet high tower. So we bought material, cut material, blood, sweat, tears, late nights. We have to give credit to Dr. Dejad. We worked in his nanotech lab. Our mentors in the back, Mike Menendez and Felix Jaraba. Okay. So we have a quick video also from Hummer, who incorporated all 3 projects into one video. So here's our base for our turbine system. The foundation itself took 7 hours because we mixed the cement by hand. We had no truck. We used 304 stainless steel. We dug a lot. Our system was hand so we could raise it. So probably from the base of the mountain to the top is about 50 feet. Mike Menendez, our head mentor. Here are the shots from the UAV, which is totally autonomous, so it works on GPS mapping. All the bananas. The project was originally supposed to be next to his home, but we found the mountainside and we had that excavated and we did our project. So here's the UTV. This was worked on by about a group of 12 students plus. All recycled material.